Hello, Algebra Scholars. This is section 6.5, Complex Rational Expressions. And all that really means is that you have fractions within fractions. And you can see an example of that down here. You have a bunch of fractions, little fractions and big fractions, all within one. So to solve it, we have a three-step process. This is slightly different than the notes I gave you in class. I like this maybe a little bit better, because it's a little bit shorter and I think a little clearer. So the first step is to find the LCD. Then we're going to multiply every term by the LCD, or if it's a fraction, by the LCD over 1. We will then factor and simplify if possible. So the LCD for this problem, the least common denominator of 2, 4, 6, and 8. What's the smallest number that all four of those numbers go into? Hopefully we can see by inspection that it's 24. Otherwise we need to write out the prime factorizations of all of those. So we're going to multiply every term by the LCD, or the LCD over 1. So here's what it looks like. 1/2 times 24 over 1 plus 3/4 times 24 over 1, 5 over 6 times 24 over 1, minus 3/8 times 24 over 1. Okay, and now we're going to simplify each of these products. And here's how we're going to think about it. Let's choose a different color pen. 2 goes into itself once, and it goes into 24 12 times, so that's just 12. And then here, 4 goes into itself once, and it goes into 24 6 times, and 3 times 6 is 18. And the third fraction, 6 goes into itself once, and it goes into 24 4 times. 5 times 4 is 20. Whoops, it's supposed to be a minus sign. And in the fourth fraction, 8 goes into itself once, and it goes into 24 3 times, and 3 times 3 is 9. And up top, 12 plus 18 is 30. 20 minus 9 is 11. And we cannot simplify that at all. So 30 over 11 is our final answer. Okay, Algebra Scholars, here's a second example. In this problem, the least common denominator is just x, because we only need to look at the small denominators to find it. 2 has a denominator of 1. We don't write it in. 5 has a denominator of 1, which isn't written in. So the LCD is just x. And now we are going to multiply every term by the LCD over 1, or in this case, just by the LCD not over 1. We will do the same thing here. We'll multiply by x over 1, and here we will multiply by x. This first circle simplifies to just 1. Here we have 2x. This also simplifies to 1 minus 5x. Since these x's are part of terms, because there's addition and subtraction, that's as far as we can go. In this third example, the least common denominator of 2, 4, and 8 is 8, and of x and x cubed, it's x cubed. So we're going to multiply every term by 8x cubed, or 8x cubed over 1. Actually, we're going to multiply everything by 8x cubed over 1, because everything is a fraction. So the second fraction times 8x cubed over 1, the third fraction times 8x cubed over 1, and the fourth fraction times 8x cubed over 1. Alright, now let's clean it up and see what we've got. 4x cubed goes into itself once, and it goes into 8x cubed twice, so that just becomes a 10. Here the 8's cancel, and we're left with an x squared, but also a 3, so 10 minus 3x squared. Here, 2 goes into 1, it goes into 8 4 times, the x is going from here, and there's an x squared, so it looks like we have 12 x squared, the 3 and the 4, and then the x squared here. And then here, the last term, the x cubes are gone, 4 goes into itself once, it goes into 8 twice, and 2 times 3 is 6. Now we could factor the denominator, but we can't factor the numerator, so nothing's going to be able to cancel because we'd end up with terms on top. And even if we factored it, we'd have factors on the bottom, but you can never cancel terms. So we will call that good. And here's our last example. The LCD of this problem, once again, is just plain old x, because all we have for denominators are these two little x's. So x is the LCD. So we have to multiply every term by x. The first term, the second term, and here I'll multiply by x over 1. I'm going to do the same in the denominator. The first term times x, the second term times x, and the third term times x over 1. And now let's see what we have. X squared minus 2x minus 1, and x squared minus 5x minus 4. Looks like we can do some factoring here. Two numbers that multiply to -1 and add up to -2. Ooh, maybe we can't do some factoring here. Let's go ahead and change the problem to plus, even though that wasn't how it was originally written. So we could go with -1 and -1. So that would be x minus 1 and x minus 1. And then over here, we'll do a factor sum chart. Two numbers that multiply to -4 and add to -5. Also not going to factor. So let's go once again. Let's change this sign to plus. So -1 and -4. That's better. It's going to make it a little more exciting here because now we can do some canceling, whereas before we couldn't even do any factoring. So there you have it, my friends. Complex rational expressions.